Hey, this is Chris, and we are taking a look at questions 35 and 36 here in section 4 of SAT Practice Test 3. So for question 35, it says an online store receives customer satisfaction ratings between 0 and 100 inclusive. In the first 10 ratings, the store received the average of the ratings was 75. Okay, so average of 75 for those first 10. And then it says, what's the least value? Sorry, didn't mean to cross that out, but what's the least value the store can receive for the 11th rating and still be able to have an average of at least 85 for the first 20 ratings? So basically, in this case, whenever you're trying to find the lowest possible individual value to achieve a certain result in terms of average, you want to assume that the rest of the values are the maximum possible value. I'm sure a lot of you do this when you're calculating, what's the lowest score I could get on the final to still end up with a 90 in the class, or to still get an A for the term, or to still get a B, or whatever it is. So here, the first 10 ratings had an average of 75, and we don't know the exact values of each rating, but we can treat it as though every single rating across those 10 was a 75. So we can treat it like it's 10 times 75. Now, in reality, were some of them 68s, and some of them 82s, and some of them 76s, and some of them 63s, and so forth and so on? Of course, it could be any value that gets us to an average of 75, but an average of 75 means the sum of those 10 terms would be 75 times 10, which would be 750. So we have 10 75s plus x. That's what we're solving for here. That's going to be this least value for that 11th rating. And then in order for that to be the least value, and I'm going to color code this a little bit, but if we want this to be the least, then our goal is for the other ratings to be the greatest, right? To be the most that they possibly could be. So here, let's see how many ratings we have left. We have a total of 10 so far, plus this 11th term. And so out of our 20 ratings, we have 9 left. So we want that to be 9 times 100, because it says that that's the maximum rating that a customer satisfaction rating could be, is 100. So we want it to be 10 times 75 plus x, and in order for this one to be the least, we want this one, or all 9 of these actually, to be the most. And so here we're going to have 10 times 75, let me make that a little straighter, plus x, plus 9 times 100 divided by 20, and that average is supposed to come out to be at least 85, which means greater than or equal to 85. And now we can do a little math and a little simplification here. So that's going to be 75 times 10, which is 750, and that would be plus x plus 900 all over 20, greater than or equal to 85. Here, 750 and 900 is 1650, so we get x plus 1650 over 20, greater than or equal to 85. Multiply both sides by 20. X plus 1650 is greater than or equal to 1700. When we multiply both sides by 20, subtract the 1650, x has to be greater than or equal to 100. And so here, the least possible value for x on that, if it's greater than or equal to 100, the lowest value is 100 itself, and we would bubble in 100 for question 35. Now let's move over and take a look at question 36. In the xy plane, if a point with coordinates AB lies in the solution set of the system of inequalities above, what's the maximum possible value of B? So here, maximum possible for B. Well, here we have this system of inequalities, and just like with any system of equations, you want to find out where that breaking point is. You want to find out where your value is going to have a max or a min, which means that for these, we would have to set these equal to each other. And to do that, if you did negative 15x plus 1300, or sorry, plus 3000 equals 5x, you can add 15x to the other side. 3,000 equals 20x. Divide by 20. That would be x equals 150. So that would be one of our ends of our values, either a max or a min. And in order to figure out what that's going to correlate to, remember, if we're solving for x, every coordinate that you have written is always written in the form of xy. So if we solve for x, that means we could always plug that in to solve for y. And it doesn't matter which one of these inequalities you plug it in for. So I think the second one's probably a little easier here. So if you plug in a 150 for x, you would get y is less than or equal to 5 times 150. And that would give us y is less than or equal to 750. And remember, we're looking for the maximum possible value. So sure, y could be 0. That's less than or equal to 750. Y could be 17. Y could be 263. But the maximum possible value for y, which is represented by b in our coordinate here. So the maximum possible value for b is going to be 750. And we can bubble in